Welcome back to another video. This is Dr. Tarcia Hubert, and in this video I am going to be talking about geometric properties. Yes, we're going to be talking about some geometric properties. You may have learned these in geometry, or you may be taking geometry for the first time and just now learning these. So let's get started. The very first thing we want to talk about is what's called vertical angles. I know it's a little blurry. I took a picture and I blew it up so it looks a little blurry, but the important thing is when you have two lines that intersect, you create four angles. The four angles are found, so let me get my laser pointer. The four angles are found here. That's one, here's two, here's three, and here's four. And I have those angles labeled. This is angle QMR. This is angle RMP, angle PMN, and angle NMQ. Now you also create what's called vertical angles. The vertical angles are the angles that are directly across from each other. So these two angles that are both marked in the pink looking color, those are considered vertical angles. And these two angles in the blue are considered vertical angles. They're directly across from each other. Vertical angles are equal. So anytime you have vertical angles, they are equal. So angle NMP is equal to angle QMR, and angle RMP is equal to angle QNM. So vertical angles are equal. Vertical angles are angles that are directly across from each other. All right, so now we want to talk about parallel lines. So parallel lines are two lines that don't intersect. So these blue lines here, these are considered parallel lines. They don't intersect. So we want to specifically talk about the properties that are created when we take a line and we cross it through the parallel line. So this pink line here is a line that crosses through the parallel lines. It's called a transversal line. This is a transversal line. Anytime you take a transversal line and pass it through parallel lines, you create 8 different angles. Here are the 8 angles: 1, 2, 3, 4, 5, 6, 7, and 8. And so these angles have relations to each other, and we're going to break it down and look and see the relationships between some of these angles. First, we know that there are vertical angles. The vertical angles are the angles that are directly across from each other. So 2 and 3 would be considered vertical. 1 and 4 would be considered vertical. 7 and 6 would be considered vertical, and 5 and 8 would be considered vertical because they're directly across from each other. You also get what's called alternate interior angles. So alternate means that they are on the opposite sides of the transversal line. So remember, this is the transversal line. They're on the opposite side of the transversal line, and they're inside the parallel line. So here's an example of alternate interior angles, the 5 and the 4. They're on opposite sides of the line, and they're inside these parallel lines, okay? Those are alternate interior angles. You see at the bottom it says also 3 and 6. That's referring to the original picture. So assuming that this is 1, 2, 3, 4, 5, 6, 7, and 8, 3 and 6 would also be alternate interior angles. Alternate interior angles are equal. So anytime you have alternate interior angles, those are equal. So angle 4 is equal to angle 5 in this picture. Then we have alternate exterior angles. So alternate means opposite. That means they're on the opposite side of the transversal line. But exterior means they're on the outside of the parallel line. So here are my parallel lines. These angles are outside the parallel lines, but they're on the opposite side of the transversal line. Alternate exterior angles are also equal. So 1 and 8, and then 2, which would be right here, and 7, which would be right here, are also alternate exterior angles. Corresponding angles are also created. These are angles that are on the same side of the transversal, but one is on the interior of the parallel and one is on the exterior of the parallel. So 6 and 2 here. They're on the same side, you see, of the transversal. 6 is on the interior, 2 is on the exterior. You see it says 1 and 5 also. 1 would be here, and 5 would be here. 1 is on the exterior, 5 is on the interior. 3 and 7, it says also 3 would be here. No, 3 would be here, and 7 would be here. So 3 is on the interior, 7 is on the exterior. And then 4 and 8, 4 would be here on the interior, 8 would be here on the exterior. So those are also corresponding angles. and corresponding angles do equal also. And then the last ones we're going to look at are interior angles on the same side of the transversal. So these are angles on the same side of the transversal, but they're both inside the parallel lines. If this is the case, these angles are what we call supplementary. Recall that supplementary angles are two angles that sum up to 180. So in this case, 4 and 6 are interior angles on the same side. That means when you add angle 4 and you add angle 6, you'll get 180 degrees. Also, angle 3 here and angle, what is that, 5? So 3 and 5 would also be interior angles on the same side of the transversal. Yep, 3 and 5 here. These are supplementary angles. And so these are the different relationships that are created whenever you take a transversal line and cut it through parallel lines. So here's an example. We want to find the measures of angles 1, 2, 3, and 4, given that lines M and N are parallel. So M and N are parallel. Here's our transversal line that cuts through. It lets us know that angle 1 is 3x plus 2 degrees and angle 4 is 5x minus 40 degrees. Well, look and see, how does angle 1 and angle 4 compare? Well, they're on the opposite side of the transversal, so they're going to be alternate. And they're both on the outside of the parallel line, so they're going to be exterior. So those are alternate exterior angles. Alternate exterior angles equal. And so what we want to do is we want to take the 3x plus 2 and set it equal to the 5x minus 40. Because those angles equal. And then we want to solve for x. So I'm going to subtract the 3x from both sides just because it's smaller. And you get 2 equal to 2x minus 40. I'm going to add the 40 to both sides. And you get 42 is equal to 2x. And then we need to get rid of the 2. So we'll divide both sides by 2. And we get x is equal to 21. Well, if x is equal to 21, then we have to find the measure of angle 1 by replacing x with 21. So that'll be 3 times 21 plus 2. 3 times 21 is 63. Plus 2 is 65 degrees. So we know that angle 1 is 65 degrees. Well, we also know that angle 3 is vertical to angle 1, and vertical angles are equal. So that would also be 65 degrees. We also know that angle 1 and angle 4 equal, so that would also be 65 degrees. So angle 1, angle 3, and angle 4 are all equal. And they all equal 65 degrees. The only one that's different is angle 2. Angle 2 and angle 1 are supplementary angles because they form a straight angle. So we can find the measure of angle 2 by doing 180 minus 65. When we do 180 minus 65, we get 115 degrees. So angle 2 will be equal to 115 degrees. And so we found the measures of all 4 angles. Angle 1, angle 3, and angle 4 equal. And angle 2 is 115 degrees. All right, let's look at another one. All right, I want you to give this one a try. Take a moment and pause the video. I want you to see if you can find the measures of angles 1 through 7. So take a moment and pause it and see what you get. All right. Well, it tells us that this first angle here is 131 degrees. Well, we know that angle 3 is vertical to that angle. So angle 3 is also going to equal 131 degrees. We also know that angle 7 is a alternate exterior angle with 131 degrees. So angle 7 is also going to equal 131 degrees. We also know that angle 4 is a vertical angle to angle 7, so angle 4 is also going to equal 131 degrees. All right, so we got angle 3, angle 4, and angle 7 all equal to 131 degrees. So now we can find angle 1 because angle 1 is supplementary with that 131 degrees. So angle 1 is going to be equal to 180 minus 131. 180 minus 131 is 49 degrees. So angle 1 is equal to 49 degrees. Well, angle 2 is vertical to angle 1. So angle 2 is also going to be 49 degrees. Angle 5 is an alternate interior angle to angle 2. And alternate interior angles are also equal. So angle 5 is also going to be 49 degrees. And then angle 6 is vertical to angle 5. And vertical angles are equal. So angle 6 is also going to be 49 degrees. So angle 1 is 49, angle 2 is 49, angle 3 is 131 degrees, angle 4 is 131, angle 5 is 49, angle 6 is 49, and angle 7 is 131 degrees. Did you get that? Hopefully you got that. If you have any questions whatsoever, just include them in the chat below and I will respond to your questions, okay? So these are just a few of the geometric properties that are formed from taking a line and crossing it through some parallel lines, and also from taking two lines and intersecting them. If you have not already, go ahead and hit that subscribe button, and I will see you all in the next video.